Please welcome to the stage the co-founder of Sanctuary AI and SingularityU Canada AI and Robotics faculty, Dr. Suzanne Gildert.
How are we all doing today? That was a great poll. What's with that? You guys are more optimistic than I am. It's a little weird, okay? So what I'm going to talk about today is something that I'm very passionate about, and that is what we can learn about being human through robots. So what does it mean to be human? There's something very interesting about being in the physical presence of another human being. It's the reason why everyone here today came here in person, rather than just watching this kind of thing on the internet. There's something really interesting that happens when you look another human being right in the eye. You see something there that's going on in their mind, behind the scenes. You feel a certain consciousness. I trust that everyone in the room has had this feeling. Have you ever tried that thing where you stare someone in the eye and you try and maintain eye contact for more than a minute? It's really, really hard. And that's because there's something special going on in our minds. So I want to ask the question, why does this only apply to humans? Can we build machines that are like us? Can we get that same feeling, that essence, that spark of life about what it means to be human? Can we put that into machines? This is a question that I've been trying to answer for the past decade. And the way that we're doing that is, at my company Sanctuary, we're building these things that we call synths. So synths are ultra-human-like robots. We want to build machines that are indistinguishable from humans physically, cognitively, and emotionally. That's our mission. That's what I'm passionate about. I want to answer the question, what does it mean to be human? Can we put that essence into a machine? Okay, so how do you go about doing this? Like, where do you even start? You want to build human-like robots. Okay, so the first thing you need to do is build a body. So what we do is we start by looking at what a body is made of. So you need perception systems, you need cameras, you need sensors, you need microphones. All those parts get data from the environment into your system. And then another thing that a physical body needs is the ability to move. You need actuators. You need some way of actually taking action in the world. And what we're seeing now is that exponential technologies are making all these things very, very easy. So there are new types of actuators coming online all the time that allow building robots to be much cheaper and faster than it was before. New sensors are enabling us to absolutely cover a robot's body in a perception system so that it can understand the world like a human. New battery and power technologies are allowing these robots to become mobile so they can carry their own power around just like we do. And technologies such as generative design enables engineers to design robots faster and make them more beautiful and organic than ever before. So in case you're wondering, generative design is when you don't actually sit down and design the robot yourself in front of the CAD system. You just put in the constraints. Say, I want this part here to withstand this force. I want this part here to be able to move at this speed. And then you hit go, and an algorithm actually designs a piece for you that satisfies all those constraints. So then what you can do is you can actually take this design that an algorithm has created, and you can 3D print those parts. Now, those parts that make the chassis of the robot. This is a video of a part being printed in our lab. So we're a relatively small company. We have a lot of really cool 3D printers. This one allows us to print in carbon fiber with inlaid Kevlar, which means that the robot chassis is stronger than aircraft-grade aluminum, half the price, and it takes about 1 to 10% of the time to actually design and fabricate this. So these technologies are really advancing quite quickly. So, okay, you've built a cool robot chassis. Now you make it move. So what we do is we build these ultra-human-like robots, and We make them move. We make them take actions in the world. And what we do initially to make this happen is we animate them. So we use technologies from the video game industry. This is how people animate video game characters. We make the robot move in the same way using these techniques. You can get some very cool, smooth motions, and all that advancement that's gone into making avatars more realistic, making video games more realistic, is now being put into human-like robots. So again, this is a technology that we can leverage. Okay, so you've built a robot. You've run some animations on it to show that it moves smoothly and everything works really well. But now, what you have to do is something different. So you can't just move forward forever by animating the robot. It doesn't work like that. Because that robot has to go out into the world and experience things it's never seen before. So it needs to move in a way that, it's not, you can't just pre-program that into an animation. So what we do now is we use something called teleoperation. So we've got the robot, it's able to move, it has the potential to do almost anything a human can do. So now we make it do everything a human can do using a teleoperation system. And what this consists of is a human puts on an array of different technological artifacts. It could be an exosuit, but it could be something as simple as hand controllers or even a keyboard-mouse interface. And with UI advancements and very clever control techniques, you can make the robot move in a way that's perfectly analogous to what the human is doing. And here, the video feed from the robot's cameras can be sent to the pilot through a head-up display. When the pilot's head moves, the robot's head moves, and you get this really immersive experience that you are actually the robot. So we've already discovered an interesting little thing here of what it might feel like to put your consciousness into a robot. And I'll come back to that a little bit later. As an aside, I had a really interesting experience once where I was doing this for several days, and then I actually had a dream that I was the robot. Like, I was dreaming that I was no longer in my physical human body, but my brain was now in the robot body in my dreams. Isn't that really interesting? Our minds are very malleable. They're very open and accepting to new experiences. So here's a short video of some of the teleoperation technology. This is actually using one of our earlier prototypes, but you can get a sense of what's going on here. So you can see the robot moving, and then you'll see the pilot coming in and starting to take control of the robot. So this is really cool. We've got some awesome teleoperation stuff in our lab, but you can't have that in everyone's home, right? These things are expensive prototype systems. But what's going on in virtual reality is that this kind of stuff is now being commoditized. So all the technology and all the dollars that are going into VR technology to make these really immersive, real-life experiences in VR can also be transferred over to this robot technology. So what this is going to enable is when robots start proliferating out there into the world, they'll all be pilot-controlled, and there'll be thousands and thousands of pilots all over the world who can jump in and take control of a robot at a moment's notice. And they'll be able to switch between different robots. And there'll be some system where they're able to, say, gain credits for doing tasks as robots. They'll be able to do useful physical and social labor as robots. So this really enables a new kind of platform for work, for the future of work. Now you don't need to be in the same place that the work needs to be done to do the work. So imagine how much friction this removes from the labor market. You've got all these people all over the world from every country who have the ability to now log in, take control of a robot, do some work, gain reputation, gain an income and a salary. It's just amazing and mind-blowing to think about that. So, okay, what's going to happen? So you're going to have these robots controlled by people. So imagine you walk into a retail store, and you're greeted by a synth. And that synth knows who you are because you've been in there before, and robots can have an eidetic memory. It knows what you like, and it can recommend you some nice goods. The robot could be your personal stylist. Or imagine that you walk into a doctor's office, and you need to see a physician, and you're now seeing a robot physician. So that robot can provide to you, it can have all your medical history, it can provide you with a physical exam because it's a physical robot, and because it's got that human social interaction touch, it can also provide services such as counseling and therapy, things like this. Again, it's those one-on-one social interactions in the physical world that I think this technology is really going to excel at. Okay, so that's cool. So far I've talked about robots. I've talked about teleoperation, talked about people piloting robots and doing work and improving labor, but it doesn't stop there. Of course, if you're a company providing this service, you want to increase your profit margin, so you're going to start trying to automate parts of this process. Automating work means that you have to start adding some AI into the system because you want systems that can make decisions in the way humans do. And we can start doing this straight away with some existing tools. So even today, we can take a bunch of AI tools from many, many different companies, many, many different providers, and we can put those into the robotic platform today. So this is straightforward, and it's something we're doing already. So all those billions of dollars that's gone into the development of AI can be leveraged through this kind of platform. So what does that get you? Well, it gets you a robot that can do certain tasks automatically. So say you had a retail store and you wanted to attract customers, an AI system could just look for people coming past and wave at them and say, hey, do you want to come in and check out our goods? And then what can happen after that is once the person comes in and they start asking a question that the AI can no longer handle or answer, then it can seamlessly switch over to a human pilot, and the human can now take control. And that process can be, completely transparent. You can either have people know that this is happening or have them not know it's happening, depending on how you architect the system. So what we'll see is that there'll be this crossover period between, say for a relatively simple task, between predominantly pilot control, which is what we have today, with the AI maybe jumping in and doing little parts of the automation throughout, to, in something like 2 years' time, those AI programs being able to automate the majority of a task. So what this means for the pilot is that they now become more efficient. So a pilot can now control, say, 10 robots at the same time instead of 1 robot, because they only need to use 10% of their concentration of their duty cycle on each robot, and the AI takes over for the rest. So I see there being this crossover point between piloted teleoperation systems and systems that are predominantly relying on these existing AI techniques. Okay. It doesn't end there. The problem with these existing AI techniques, I'm sure anyone who has conversed with an AI or interacted with an AI hasn't had that spark of life experience yet. So this thing I'm talking about, when you interact with another human, that doesn't exist today in AI. It's very functional. It's answering questions for you. It's making calendar appointments. It's ordering something online, or it's recommending you a movie. Those are all great things, but they don't have that sense of you having a real social bond with that AI. There's no humanness to it. But I believe that we can get there, because after this crossover phase into these existing narrow AI solutions, we're not going to stop there. We're going to keep going and go further. And what we're going to do is start moving AI systems closer and closer to human-level AI using research that's happening today into cognitive architectures, into the brain, and into neuroscience, and into how our mind really works. So what you see here is just a very simple high-level diagram of how a cognitive architecture might work. And how this is different from existing AI solutions is that you actually put together many, many, many different pieces of AI from many different fields, and you create something that works more like a brain than an algorithm. So for example, you have a physical body, you have a robot, it has a perception system, and it needs to get data in. There is a lot of data coming in to the robot from the physical world. So you can use deep learning techniques and other neural net models that are designed to reduce all that data to a few simple labels. Once you've got those simple labels, you can now pass them into a bunch of different AI solutions that try and figure out what action to take in different ways. So if any of you have read the book Thinking Fast and Slow, this is one way of thinking about how to architect a brain. So you can have some AI pieces that take that incoming data and make a really snap decision about what to do. You might think of this as like a reflex system, or an instinct, or a fear response, or something like that. And then on top of that, you can stack AI techniques that are more smart and think a little bit further into the future and do more planning. And maybe those ones can't act straight away. You wouldn't want those to be working if, say, a car was coming towards you, but those ones allow the AI to do long-term planning. And then when an action has been selected, you can unroll that using these things called generative models, which take a symbol and they expand that into a complex action that could, for example, drive a robot's motors. So when you start putting together all these different pieces of AI into a cognitive architecture, into a brain, you can architect things that are much, much more like how animal cognition or how human cognition works. And this is the bit that I am super excited about, because I believe that within 10 years, we're going to have these architectures, and they're going to capture that spark of life. They're going to enable us to build robots that seem ultra-human-like when they're in full autonomous mode. So, okay, I'm going to summarize what I just said, because I'm sure quite a lot of you are suffering from future shock and confusion at this point. So here's a little summary. So initially, from now onwards, there'll be this teleop phase, where humans can take control of robots, and during that phase, robots will be normalized. So if you know that a human is controlling a robot, it doesn't quite seem so creepy or scary anymore. It's just like an advanced telepresence system. It's like one of those beam robots that rolls around, or it's like a video conference, like Skype or Zoom or something like that. It's just a human behind the scenes. But what's going to slowly happen is that narrow AI, those fragmented pieces of existing AI are going to come in, start taking over little parts of the control cycle, until they're almost dominating what's going on. But you can never get rid of that last part, that like needing that human connection, and that's where this human-like AI R&D comes in. And I believe by 2029, that will be the majority of what's going on in humanoid robot research, is how to make the AI minds more like brains. So I think within 10 years, we might be seeing something that we see in science fiction. So we've all seen these robots walking around in science fiction, like Ex Machina, like the robots you see in Westworld, like the character Data from Star Trek. Can we get from where we are now, which is the very initial nascent phase of this, to something like those sci-fi robots within 10 years? I think it's possible. I actually think it's likely. That's why I work on it. And I'm very excited about that poll, because I think a bunch of you guys think it's possible too, which is really interesting. Now, I haven't said anything yet about whether this is good or bad. That's the question, right? Should we actually create these beings? A lot of people are really scared of creating things that are like us. They're very scared of putting AI into a form that is overly familiar. It evokes in us something called the uncanny valley, where as something gets more and more human-like, it actually becomes more and more creepy and scary. But I think we can actually get through the uncanny valley. I think we can make these things so human-like, and we can normalize them using teleop and other techniques, that we will start to feel like these are beings that have come into our world, come into our presence, and we're going to start treating them more and more like other people. This is a scene from a deploy we did of one of our synths into a local science center in Vancouver. And it was amazing, like people were crowding around, they were interested in the robot, they were very engaged, and I'd never seen anything quite like this with a new piece of technology like a screen or a virtual avatar or something like this. This was a different feeling. And looking at this image, it reminded me of something. So thousands of years ago, we used to live in small social groups, tribes. And we used to sit around the campfire, and we used to socially interact and bond with the other members of our tribe. And I think that's what's represented by all the people here surrounding the synth. That's the tribe we're used to. But imagine what happened when one day a stranger from another tribe wandered in towards your campfire. So what do? Now, a lot of tribes that are in this situation will want to kill that thing immediately. Get rid of it. Destroy the other. It's a threat. It's not like us. We don't want that here. And that is the reaction I think a lot of people might have to synths. But imagine those tribes that behaved slightly differently. Now, in some cases, it may have been unlucky for them, but in some other cases, it may have been a very good idea to say, hold on, wait. Why don't we see what this person does, see how they interact? Maybe they have something to teach us. Maybe they have something to trade with us. Maybe embracing them, allowing them to come in a little closer to our tribe, allows us to learn something new from them that gives us an advantage. I see a situation now where this is happening all over again. Except the stranger that's coming into our tribe is not a human. It's now a synthetic human. It's an embodied AI. So there's two reactions. We can be scared of that because we've all watched a lot of sci-fi and we know how that ends. Or we can maybe be curious and open-minded and wonder if there's something we could learn about ourselves. Is there a way we can improve ourselves and our civilization by allowing these new beings to come in, teach us, trade with us? It's our choice. We can choose which of those futures we want to have happen. Of course, it's not all great. There are a lot of issues with this technology, and it's going to be a rocky road ahead for both synths and for humans. Some of the issues with synths are things like data privacy. So all that data that's coming from the environment into the synth's brain, if you're a human, we treat that differently than if you're a robot. So your eyes are actually just eyes, right? If you're interacting with someone, you don't have to have them sign a consent form to have your eyes look at them, take your data in. But with a synth, you do, because those are not eyes, they're video cameras. So how are we going to bridge this gap between a synth being a bunch of technology that's collecting our data and a synth being a system that's a being, that's something very like a human, that's actually using that data to form experiences and memories of the world, and not just capturing it for some like corporate profit-making use? We've got to bridge that gap. I actually think that within that 10-year time frame, these synths are going to start asking questions about their own rights, their own place amongst us, and potentially their own citizenship. So I don't think it's unrealistic to imagine that a robot might be questioning whether it should be a citizen or not within 10 years. I find that quite exciting. Other people might find it quite terrifying. Okay. Final thought. In the future, there's going to be synths and there's going to be humans, right? That's what you are all answering about the poll. There's going to be human-like robots walking around amongst us, right? I don't think that's going to happen. Or at least, I think that's a subset of what's going to happen. I actually think one of the key reasons for building human-like robots is, and bear with me here, follow my argument, the signals that go into that AI, that go into that robot's brain, if you can make the human-like robot human-like enough, those signals will be really similar to the signals that are going into our own brain. If you can architect the mind so that the brain is organized in a similar way to our own brain, then maybe those signals are processed in a similar way. And there's another technology coming on the horizon called brain-computer interfacing. And you'll hear a little bit about this later on at this event. But what I'm interested in is, can we interface our own brains and get those signals out and maybe swap or share those signals with the signals that are coming in from these robot bodies? Can we somehow wire our brains into robot brains? So we built robot bodies. We can teleop them so we know that they move like us already and we're used to controlling them. We built AI systems that are very similar to how our own minds work, and we have all that data coming in and out. The missing piece is connecting into our own brain. Once we've done that, the possibilities are endless. So what I think is going to happen is, in the future, there won't just be synths and humans, there'll be synth humans. Or there'll be some blend of a synth and a human. So maybe a human brain directly controlling a synth, maybe a synth brain directly controlling a human body. Maybe a human will have some synth parts. Maybe a synth could be made better if it had biological parts going into it instead. It'll be this blending, this beautiful, diverse spectrum of everything from pure robot to pure biological human. And I'm super excited about that. But the thing I'm most excited about is what this means for learning what it means to be human and what it means to be a conscious, sentient being in the world. So if you can hook your brain into an AI system that's controlling another body, what would that feel like subjectively? Might you be able to feel the consciousness of the other being? Might this finally help us explain what on earth consciousness is? We might be able to do science in this new realm once we've hooked our brains into the consciousness of others. So lots of people are excited about going to space, exploring what's out there, exploring the galaxy, outer space. I'm excited about that too. But I'm also excited about opening up a new inner space that we can also explore. The frontiers of the mind, the frontiers of our own understanding of what it means to be human. We know relatively little about consciousness, what other beings experience and feel. Maybe this could be a tool with which we're able to probe that new world. This is why I work on this technology. And I think through robots, we can ultimately directly feel and learn what it means to be human. Thank you.